right, so here what we're going to do is we're going to be taking those functions that we were playing with, converting from hydrogen ion concentration to a pH and relating hydrogen ion concentration and Kw, and we're going to kind of consolidate those things, pack them together. So here, first and foremost, we know that Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration. And if you are kind of forgetting some things, well, this OH minus, oxygen and hydrogen like to pair up with one another and form a polyatomic ion known as our hydroxide ion. So the concentration of a hydroxide ion times the concentration of our hydrogen ions is equal to our Kw, which we know that our Kw is going to be 1.0 times 10 to the negative 14th. Always. Done. Okay. Now, if we wanted to figure out, or if we want to put all of it together, we would say negative log of those concentrations is equal to negative log of the Kw. Negative log of our hydrogen ion concentration minus the log of our hydroxide ion concentration is equal to the negative log of Kw. Okay. pH, something that we're familiar with, POH. That's a little bit of a different thing. So this right here, that negative log of our hydrogen ion concentration is our pH. The negative log of our hydroxide ion concentration is our POH. And the pH plus the POH, those are going to equal the negative log of our Kw. Well, I'm going to erase some stuff real quick. Another way to look at this is pH plus POH is equal to negative log of 1 times 10 to the negative 14th, which is the same as negative log of 10 to the negative 14th, which is the same as negative 14. So pH plus POH is equal to 14. Now that idea right there is a very important one for you to remember. Similarly, it's a way of looking at, or it's basically a connection between our hydroxide ion and our hydrogen ion concentration equal to 14. So we typically look at things and we ask questions about, well, what is the pH of a solution? Well, if the pH of a solution is 3.6, you can also figure out your hydroxide ion concentration, or the negative log of your hydroxide ion concentration, also known as your POH. If the pH is 3.6, your POH is 10.4, because those two numbers are going to add up to 14. Now this is pretty central to lots of your homework problems. I finished the chapter number 16 homework a little bit ago, and you've got tons of questions that just deal with understanding and remembering that pH plus POH equals 14. Okay. Now, anytime that you see that lowercase p, think that that means that you're taking the negative log of whatever number that follows. Just as POH means the negative log of your hydroxide ion concentration, and pH means the negative log of your hydrogen ion concentration. pKw means negative log of Kw. Now, let's look at an example here. The pH of a strong acid. We've talked about strong acids versus weak acids. And for the time being, let's talk about a strong acid. What we know about a strong acid is that HNO3 here will totally dissociate 100% into H plus and NO3 ions. Okay. Now, knowing that this is a strong acid and knowing that it completely dissociates is super important. Because if we know the concentration of nitric acid, HNO3, and we add water if we know the concentration of nitric acid, then effectively we know the hydrogen ion concentration, just because this is a strong acid. Now, this HNO3 concentration we can look at as being equal to our hydrogen ion concentration. So we can say negative log of 0.25. I'm going to plug that into my calculator on my computer. And I'm going to figure out that whenever I do that, I've got a value of 0.602. So is that a neutral, basic, or acidic solution? Well, that's an acidic solution. The pH is below 7. Not only is it acidic, it is super acidic. Okay, that's because nitric acid is a strong acid. Okay, now let's talk about a strong base. Find the pH of a 0.25 molar sodium hydroxide solution. Okay, this is a little bit trickier. So we know that this is a strong base, so it will totally dissociate. It will totally dissociate into a sodium ion, Na plus, and OH minus. Okay, we can effectively say that our 0.25 molar is equal to our hydroxide ion concentration. So we can say negative log of 0.25. Now we just did that, and we figured out that this would be 0.602. Okay, but let's think about this. Did I just solve for my pH? I didn't. I solved for my pOH. So my pOH equals 0.602. My pH, by contrast, pH plus 0.602 equals 14, so minus 0.602, 602, and I get 13.398. So effectively 13.4. This is my pH of a sodium hydroxide solution, or a 0.25 sodium hydroxide solution. So how would I classify that? Acidic? No. Basic? Totally. And very basic for that. Okay. Next up, the pH of a strontium hydroxide solution. It's also a strong base. Well, you know what? I think I'm going to go ahead and save us all the stress of this and say, well, negative log 0.25 equals 0.602. My pH is going to be 13.398. And there we go. That's all there is to that sort of problem. Okay, I hope that was helpful.